All right, I hope everyone's doing good tonight. So welcome to our sort of Unity tips and tricks for coding in, well, Unity. Um, this is a workshop that's gonna, it's gonna range from beginning to more advanced tips and things. So if you're just starting, hopefully there's some stuff you can learn from this to get you going. If you're more advanced, you might know a lot of things already. Hopefully there's some neat little tidbits that you can start applying. I will say for those who are beginners, if there is something that confuses you, feel free to ask questions. I'll try my best to explain. But also there's some stuff that might be just advanced that it's okay to come back to later. All right. Let's get started. First thing first, I want to say if you want to follow along, I'm going to be using 2020.3.21. Feel free to use really whatever version. A lot of this stuff is pretty universal. Some of it might be more specific to 2020. So as long as you're using a Unity 2020, you should be fine. And if you don't have Unity, you can go download it from just their website, get the Unity Hub. That's the best way to get the installs. Yeah. And before we get in, I want to show this off. A lot of the stuff I'm covering here tonight can be found on Unity's scripting API. I'm going to start off by showing this is a really good API and resource. Unity puts it together, and literally anything that you may need. Okay, how do I raycast? And you can just sort of search. There's all sorts of different things in here, but including examples, different variations. It's a really good resource. I do recommend it. Okay. So, first thing first, I'm going to start off with talking about some Unity functions and things. This is your backbone of coding, right? If you ever created a script in Unity, then you've seen it comes with update and start, right? And that's how most of your code is going to go in those. And so I want to talk a little bit about maybe how you can use these different functions that are of Unity and some like special quirks from it. First thing first, I want to show off this on the Unity API documentation. They actually have this really neat chart that shows when these functions will occur. And we're going to get back to this. This is confusing. It's okay. I just want to bring it up, and we're going to actually get back to this. And now let's actually get into these tips. So when you create a script, you're going to see one of the first things is start. Well, similarly, there's awake. So we have awake and start. And they pretty much do very similar things, but there's small little differences. The first and foremost is that awake will always occur before start. And this, we can actually see, I should put this on a different tab or something like that, on our order of execution. That's not working. So the very first thing that ever happens on a script is going to be awake. And then there's a few other things that occur, and then start. So this is important. You could have start and awake on the same script, and they both will occur. But awake will always occur before the other. Let me. All right. So I have an example project that I have a bunch of test scripts and example scripts set up for y'all to show off what I'm talking about. And first off, let's check out this function script. I've seen some people taking photos and whatnot. Feel free, but I am going to post these slides later. I'll probably make some more adjustments to them so that they're more readable instead of for presentation. So feel free for that. We'll also have a recording of it. Yeah. On the Discord, most likely. Yeah.
Will you make sure the project files and other pieces?
I can do that. It's actually up on Git right now, and I could share that link, but also I can share just like these files. This right here is a bunch of just examples of the, and but yeah, I can try to do that. Okay. So hopping right into code. Again, sorry if you haven't really coded much before, so bear with me. But I have this simple script that just prints out some statements, and you'll see that we have a start and a wake. I'm going to comment out these. We'll worry about it in a bit. And again, you might already understand, might know start and a wake, but just for proof of concept, if I run the game, you'll see here that awake occurs before start. Cool. Unity didn't lie. But what you might not know is awake has a little bit of extra functionality. So in Unity, right, you have objects and they have components on them. This one has this testing function script. If I turn off this, then typically this script is not going to run. But awake will still occur. So even though that this component is turned off, awake, whatever code you have inside that function is still going to happen. But what's really interesting is even if I have this on, if I turn the object off, it does nothing. Why? I don't know. I was talking to a coworker earlier, and they said it used to work the same way as turning off a component in previous versions. So this might be a 2020 and on, but that's a fun little thing about awake. So only it will run if the object is on. Yes.
How, is that used in practicality?
I don't know. It's like literally that I found out earlier today. I knew the disabled thing, and I thought it was object as well. And I was talking with some coworkers, and it's like,
No, I meant
No.
like running on wake up.
oh, okay. Yeah. So typically, so start and awake will only ever occur once. So this is where you want to initialize variables. This is where if you're like a lot of setup, right, for a script, this is where you want it to occur. Additionally, let me show this off. So whenever if you have things that will happen whenever you load into a scene, you want these to occur on start or awake. If you have an object that gets spawned in or is disabled on start and then you turn it on, both of them will actually run because they are now turned on. So this is going to be, your initializations, the things you want to do, typically get getting components and variables. Let's go on. So similarly, there are functions called onEnable and onDisable. You can probably guess what they do. These ones will, similar to start, whenever the object's turned on onEnable will occur. When it's turned off, onDisable will occur. Difference is, these can occur as many times as you want. So if I actually just go back here, I have these already set up. Save the script, go back over. Let Unity do its thing. You probably already guessed what's going to happen, but to show you, nothing occurs, object's turned off, turn it on, you'll see awake, onEnable, and start occurs. Now what's interesting is onEnable occurs between those two, so use that as you will. Only in very specific situations are you going to need to know the fact that these occur before each other and whatnot. But if you're coding down the line, you probably will come to these edge cases and stuff like that. And if I turn it off, onDisable will occur. If I turn it back on enable, and that's what you would expect. So those are some pretty basic functions. The other basic function of Unity you're going to use all the time is update, of course. If you create a C# script, it's going to come with start and update. But update comes in, I guess, 3 different flavors. Um, First and foremost, you have your basic update, and this is going to, basically this function gets called every frame. So if you have a game that's running at 60 FPS, then this function is going to be called 60 times a second. But then you have a couple other alternates of that. Late update does literally the exact same thing. It's going to do it every frame, but it's going to happen a bit different at a different time in that frame. There's a whole bunch of calculations Unity and the computer does, which, again, I'm going to refer to this. This is a really good chart. So where we have update, we have late update. There's a bunch of game logic and things that occur in there. And you might be like, well, why would I use that? There are, again, very specific cases. One of them being, if you are moving a camera, it's typically better to put it on late update so that other things occur first, and then it can better move and render, and it makes it smoother. It's a weird situation, but that's like the one case that comes to mind where you would want to use late update. And the final one is fixed update. Fixed update occurs at a fixed time step, and which is always independent of frame rate. So I think Unity's time step by default is like 0.2 something. I don't know if that's, say you had a game, yet again running at 60 FPS, this might run 30 times a second instead. But then that game, it lag spikes, goes down to 20 FPS for a second. This is still going to run 30 FPS. Or not FPS, but 30 times in that second. So regardless of frame rate, this will always occur. Now what's important about that is if you are moving the player, doing physics and stuff like that, you need these independent of frame rate, otherwise you get fun mechanics and things where if you have a higher frame rate, it's gonna change. So I don't know if there's some examples. Dark Souls 2 or 1, I think it was. It was 2. The weapons had durability, but it was based off of frame rate. So when they like remastered it to 60 FPS, all the weapons degraded at double the speed than the original 30 FPS.
Also, whenever they collide in the environment.
Oh, really?
Yeah.
Yeah.
There was I think in Resident Evil 3 or something, your knife deals damage based on FPS.
Oof.
Oh, man.
Yeah, or I think Fallout 76 had movement based off FPS initially, which that's the typical thing that you don't do. If you do it, I have a tip later, but you use a thing called time.delta time to make sure it's independent frame rate. Basically, it was people were able to like look into the ground, it rendered less, and then you could, yeah, you can move faster by just looking down on the ground. So there's definitely a lot more use cases for fixed update than there are like late update. And yet again, I have examples of this. Just create variables. So if I turn this script on, you will see this is a console outputting every frame update, late update. If you notice, it's always update and then late update. And then you'll see sporadically late update. You can see that they are separate. Or if I can collapse this, and you can see these numbers, update and late update are just going really quick. I'm getting, I don't know, 150 FPS. So 150 calls every second, where fixed update is getting much less. And so it's always consistent. Cool. Any questions so far? No? Cool. Yes.
What was everything you just said?
Okay, so no.
I was listening. I just didn't understand it.
That's okay. I guess my best advice would be, we'll have a video. I might even do a separate video explaining better as you can probably tell, some of this is on the fly. Um, and if you're new to like coding in Unity, that's okay. So take what you can from it, and hopefully eventually some of the stuff will come to you. But yeah, also like feel free to ask specific questions, me or any other officers later. But yeah, yes.
So, update, based on what you said, seems like super unstable depending on like people having different computers. So why would you want to have something
Right.
that over fixed it?
That's a good question. It's unstable for like specific like movement and stuff like that, but for most game logic, it's okay. Like it's good. Fixed update just might not occur enough times. If I'm like pulling for input, for instance, I probably want it at every frame. Yeah, as you could see, the fixed update was occurring much less, and so you probably want checks and certain logic occurring much quicker. That it's okay if it's like slowing down and this and that. There's just specific instances that would be such as movement that you would want independent of frame rate. Yeah.
If physics are occurring on a fixed update, does that mean we should be like, when we're working with like rigid bodies, we should be multiplying by delta time and those sort of calculations?
If you're asking if you should multiply by delta time in fixed update, you don't need to.
Well, no, I mean when we're like calling functions onto rigid bodies, right? Like with the position.
Oh yeah, probably yes. If you're doing it in update, I guess it would depend on the function, but it is probably something you want to consider and test while you're doing it. Yeah. All right, I'm gonna go on. So just keep going through a bunch of these Unity functions. Just gonna throw them out there and hopefully learn a few things about that. So next thing, very popular functionality of Unity is its collision detection. That's good old fun. So you have two flavors of, again, collision detections, and that's going to be on collision and on trigger. Both are going to do the same thing in that they will detect that, hey, something's touching a physical collision, and I'm going to activate either on the entrance of one, on the exit, or if something's still interacting with it every frame, it will you can have a trigger. Difference is there's on collision and on trigger. So I have this box collider on this game object here, and on it is a Boolean value called isTrigger. If you have this turned off, it will physically collide with something, which I will show here. So this box has a rigid body on it, so it has physics. When I go to the scene, you notice there's some weird interactions with it because the box is physically pushing it out. It's colliding with it. Additionally, I have a function set up, and you can see there's a collision with physics cube. If I turn on isTrigger, go back to the scene. Now I don't get any of that weird functionality of it like colliding against it. It's almost as if it doesn't exist. Instead, these are used as your like triggers, right? So you might walk into something like a player might walk into one of these and a sound effect occurs or something like that. A cutscene starts. I have it set up. You can see every time I enter this cube, a trigger enter goes up. And every time I exit, trigger exit goes up. And every frame it's inside of it, you have trigger stay. So this in code is right here, each one. So we have an on collision enter, we have an on trigger enter, on trigger exit, on trigger stay. All of these are default functions in Unity. They come with, you can get what you're colliding with. In this case, I had an object called physics cube, and so I was able to get the game object and the name, and then display that. You can get the syntax for any of these on the Unity API. Look those up. Also, if you are like coding on like Visual Studio, by typing in like on trigger, it should autocomplete, and I can press tab and it'll fill in everything for you. So all of these functions I mentioned, you should be able to do that. Yeah. And lastly, I just want to point out two other more somewhat used functions. One is called onDestroy, which I have here, which you could probably guess when an object is destroyed, this function is called. So it should only ever occur once. If I play the game and I click on this function testing, if I delete it, we get a function testing has been destroyed. So you also get an on disable because technically disables as part of it. And of course, you would typically destroy through functions through code and whatnot instead of like through editor, and so that's where that would occur. And then lastly, we have on draw gizmos, and I could spend time on like explaining like there's all sorts of different like cool functionalities you can do with gizmos, but gizmos are basically just a way to like show things in editor that aren't going to show up in game. It's more used for like debugging or help your designers and stuff like that. So I actually have this like wireframe cube here, and this is the size of the box. It helps me see the actual collision I have, and all I'm doing is I'm changing the color of gizmos, and then I'm telling it to draw a wire cube. So I recommend if you to just mess around with on draw gizmos. And if you just type in gizmos, there's all sorts of different cool functions you can do. Draw spheres, lines, and stuff like that. And then that will always render, like even though I'm not playing the game, this will still draw. And then I can turn that off by like literally clicking on the thing that calls gizmos. So use those, they're pretty neat. Yeah. This one does. I set it up specifically through code to do so. It's taking it's drawing the cube at the position of the box I have it on, with the scale of the box. So since my collider is the same size of my box it is, but if I change things up, it doesn't necessarily mean it is.
This would show up for the player as well as in the kind of pre-play we have right here?
This would not show up for the, like, if it does and doesn't. If I'm testing, I can turn on in editor gizmos. There's a thing you can press, and so this is the game view, and it will. But like if I created a build or just a individual executable, it would not. This is mainly just for testing and debugging. Yeah. Cool. And those are all the a bunch of the functions. There are probably a couple others out there, but these are the most common ones you're going to use. Otherwise, you're going to write your own functions. Next, I want to talk about some really neat things to do with variables in Unity. After I take a drink of water. All right. So, first things first I want to talk about is actually displaying variables in the editor. So, you have a variable, but you want to be able to change it in editor. A lot of times when you're learning Unity, you'll learn that you can do this by just making it public. If you make a variable that's public, then you can see it in the editor, which I have the same thing here. I'm going to just turn these off. Don't need them for now. And I have a variable testing. So all of this stuff is exposed in editor, and I can mess with for an object. Now, typically you can do this with public, and that's what a lot of people learn. But if you're coding, you know you typically don't want something public if you don't want another class calling it. You want to keep things private. And you can do this through a thing called serialized field. If you put this thing, serialized field includes the square brackets, then it will serialize the data and expose it on the Unity editor. Which just basically says I want to make this changeable through the editor in memory. So if I get rid of this, I just have a private value. I come in here. And that's not there anymore. So, serialized field, do that instead of public, unless you actually want the variable public. It's more proper, I guess you could say, when it comes to coding conventions. If you want to do the opposite, maybe you have a public function that you don't want to display in editor. You don't want people messing with that in editor. You can hide in an inspector. I haven't really found a situation where I ever wanted to not see it in editor, but you can if you want. So it just won't show up. Another thing you can do, and this isn't directly tied with a specific variable, but it can help organize things, is you can create headers. And it's just the syntax here. And if I go back over here, you can see I have test header. This isn't anything that's interactable, but if I come in here, it's right here, test header. And I could take this, and I have some other things here. I could do test header, but again, I'll save it, come over, and you can probably expect what's occur. And it actually organizes things into different groups. So this doesn't add any functionality, but it feels good to look at. So I do recommend organize your code. It's easier for both you and if you're working on a team, other people to work with. Additionally, there's a couple other neat things you can do to organize and make things more accessible for those who are changing values in code or in editor. One is a tooltip. And tooltips are those neat little things where if I take my mouse and I just leave it on top of function the variable, then it gives a little description of it. So a lot of times if you're for instance, I have this audio source on here as well. You might be like, what is bypass effects? Well, oh, there you go. It tells you what it is. So this is how you can write your own custom descriptions of things. And this encode just goes right before the variable. So these things that I'm showing off right now can sort of stack on each other. You could also put it all on one line. It just might be hard to read at that point. And it will apply to the next variable in there, which is going to be this test float right now. Yeah.
Is there a way to serialize a variable, not let it be changed? It just shows what it is, but you can't change it in the editor?
Yes. The exact syntax, I'll get back, if we have time, I'll get back to that one. I'm pretty sure there is a way, and I don't have that in here, but there should be. I know you can also, if it's private already, there's if I go back to Unity, if you ever want to know more, on the top right of the inspector, this is 3 dots. If you press debug, it gives you a bunch of extra information, typically stuff you don't really need to know, like instance ID and all that. But I have this private variable here, audio source. It's grayed out, right? So you can actually see it and whatnot. So if, at the very least, you can go to debug mode, but I'm pretty sure there is a way to display it here. And if anyone knows the exact syntax for that, let me know. But I'll get back to you on that. Yeah. I'm going to keep it in normal, so it's easier to read. If you have a float or an integer, some sort of numerical value, you can put a range on it, which, as you can see here, pretty much you can cap it. so that no one can, in editor, change what it should be, and you can actually just drag to where you want it. Another tool to make it more accessible for designers. As programmers, you want to make sure that, especially if you're making mechanics for others, that they're as accessible as they can be for those who are going to use it. So that's that's stuff for like showing things in editor. But here's a couple. I want to talk about a couple things for for variables in code. One is the conditional operator. This is just a neat little shorthand for basically doing an if-else statement on an assignment. So I have this string variable called description of bool, and it literally, depending on if this bool is true or false, will say whether that bool is true or false. And typically you could write this as if test bool, right? If that's true, then description is equal to so on and so forth. Else description is equal to B. So you could do that, take up like 5 lines and whatnot. Or, this is more of a C# thing than an actual Unity thing, but it's pretty nifty. You can say, okay, I want this equal to whatever the value you're testing. So it's a Boolean. You could write like a value is greater than another, or whatever you would put in like an if statement, right? Question mark, and then whatever you want to assign it to. And then I actually have an example of this. If I go to runtime, I have description bool is false, and if I turn that true, it was true. So, yeah. Additionally, another neat little shorthand is a null check. A lot of times, there's a bunch. Games are big. There's a bunch of components, and you might like get a component that you need to do things with, and for one reason or another, that component might not exist on an object. If so, Unity is going to throw a fit. You're going to have errors and be like, "Why did it break?" So, a lot of times you might put a null check, which is this top statement: if audio source is not equal to null, then I can use that audio source. Play. Alternatively, you could write all this in one line by literally just adding a question mark at the end of audio source. This will only play if it exists. So that's a neat little shorthand as well. Or alternatively, well, somewhat, there's another functionality called require component, which you can put at the top of a class that you're writing. So in this one, I have a requires component of audio source. This means if I have this script on any object, this will always have to have an audio source, or whatever other object you want it to be. And what's cool about this is if I'm just going to remove this component. If I add the testing vars script here, you'll notice it adds an audio source. So you don't then have to make sure whenever you add the script that you have all the needed values for it. It will always have what it's needed. Additionally, if I try to remove that audio source, it says, no, what are you doing? You can't do that. And one last thing with variables. This isn't necessarily specific to variables, but if I like fit in here, with C#, you can do if you do #region, and then whatever you want to name it, and then you can close out the region with nRegin. Basically, it's just another way to organize your code, right? So I have variables and functions. So someone coming in, especially once you get code that are like 1,000 lines long, you want to be able to break it up and be more digestible to read through. So break things up, make it easier for yourself and others. Yourself the next week when you realize, what was I doing last week? So That's all I have for variables so far. Any questions? Yeah, cool. All right, coroutines. These are pretty neat, very useful. I'm going to try my best to explain what they are and how to use them, and additionally a couple like neat little functionalities with them if you already are using coroutines. So, coroutines. I guess there's probably a much better like actual comp sci explanation for what a coroutine is, but basically think of them as like a function that then you can put a time delay in for it. That's basically it. But there's a couple of funky syntax you got to do to actually set it up and use it. So to actually set up a coroutine, you would create a coroutine as you would a function, where instead you might say void or the string or whatnot. You would say IEnumerator, which is this right here, and then whatever you want to name it. This then will create your coroutine, but then it needs this yield return new and then wait for, in which I'll talk about different types of wait for, but you have to have this exact syntax there. So I, after some time, eventually learned, okay, it's yield, then return, then new, and then that. And let me actually pull that up. Go to an example. Ooh. Okay, so I have some examples for coroutines in here. Actually, I'll get to that in a sec. So you need to have yield return new, and then whatever it is, and then it will wait. So the point of the coroutine is the ability to actually wait time and whatnot. Because if I just write a regular function, it's always going to occur the time it's called, right? So even if I had a really long for loop in there, that's still all going to occur in one frame. If it's really long, you're just going to slow down your frames. Or a coroutine, maybe you want something to occur in 5 seconds, or even set up a loop to occur every frame that's separate from an update. You can do that with a coroutine. To start the coroutine, you use this syntax called start coroutine. So it's you got to use a function to then call another function is one way of thinking of it. Which then, when I do start coroutine, this will then run this. And inside there, you can have it wait for a bunch of different, there's a bunch of different wait fors, which are somewhat similar to like your updates. So you have a wait for end of frame, which occurs even after late update. So that will literally wait till the end of frame before something occurs. Wait for fixed update, which we discussed earlier. I'll wait for that physics update. You can define an actual specific seconds based off of scale time, because you can actually change the speed of time in Unity. Real time, unscaled time, and then you can also wait for something to be true, or wait while something is true, so until something is false. In which I have an example to show all this. So in here, in my start, I have a start coroutine for wait example coroutine. This coroutine just literally has a yield return wait for each and every single one of them, the ones I described. And if I go back here, I just have this coroutine example 1. So you notice right off the bat, we're going to get end of frame and end of fixed update, because those are going to occur very quickly. And then I have, after 5 scaled seconds, then we get another message. After 5 unscaled seconds, another message has occurred. At this point, I have in code, it is waiting for a value to be set true, which I have here in editor. So this function will keep waiting until it gets this being set true, in which case we get bool is set true. And the opposite, we have a wait while. So while this boolean is true, it will wait, and we can turn that off, and then it will finish running. As soon as it hits the end of, since this was the last one, it'll hit the end. It is now done. It's not running anymore. It's no longer waiting in the background. So that's one way you can, one way that coroutines stop is just literally they reach the end and then they stop. But you can also manually stop coroutines through either stop coroutine or stop all coroutines, which I'll show here. Another thing about coroutines is you can actually save in Unity, you can save a coroutine as a variable itself. So I have something called a forever coroutine, and I'm going to uncomment this. I can set this coroutine to whenever I start one. So I'm starting a coroutine called wait forever, which in here is literally just a while true loop. This will not stop. And it will continue printing, and it will do this every frame. So the advantage of this is, if I just did this without that, right, in a typical function, this will forever go, and your game's going to crash. But instead, I can have the delay, and I can have it occurring every frame. And then whenever I want it to stop it, there are different ways to stop it. In this case, I have an update. If I have a boolean called stop coroutine true, then I'm calling that specific coroutine that I saved earlier, and I can say, hey, stop. No, stop. So, actually, let's turn this one off. There. So this literally will print forever, but I can just stop it, and you'll see it stops. Cool. Yeah.
If you make that false, will it start again, or is it just done?
No, it is done. I told it to stop, and so it's not a pause. It's a stop. Yeah. If I want to start again, I'm gonna have to do start. Yep. Alternatively, there is another way to stop coroutines, and it's a stop all coroutines, and this will literally take every coroutine that's on this in this instance and stop them. So I can have both of these running. So both of these are running. What if I hit stop? It will stop the forever print, and we're never going to get the second wait till seconds have passed, because all coroutines on it have stopped. So hopefully that's a quick little bit of like actually using coroutines. If you have used some coroutines before, here's a couple other like little things to know. One, you can pass parameters into it, just like a function. So I have here in this example passing into a coroutine a string value. Additionally, a neat little thing you can do with coroutines is you can actually create a coroutine at the scope level of a function. So I have this function here that's a show private coroutine. Only anything within the scope of this function will be able to call this coroutine. So this is neat because you could actually set up a function that sort of acts as a helper function instead of having to call, like, from maybe you're calling you want to start this coroutine, but you want to start it from another script. You don't have to do like start coroutine or set up a helper function and then have two separate functions. You could put it all compact together. So it's a really neat little thing you can do. in which, I mean, I can show an example of that, but so I have the show private coroutine in here, which I can call this function. Inside of it, I actually set this string value to a string, and I pass that into its own private coroutine, and at the end of frame, it runs. So, again, you can probably guess what's going to occur. Private coroutine with a passed in value. So, that's pretty neat. I actually found out about that like last week at work. So. That's coroutines. Everyone lost yet? I know we have some people sleeping. I'm sorry. I'm tired today, so I'm not too enthusiastic. My bad. It's also code. I don't know. That's just how it is. Yeah. So. Keep going. If you have any questions, make sure to stop me. All right, cool. So, next thing I want to talk about are Unity are events. There are two different types of events you can do in Unity. Actually, there might even be more, but like these are the most common ones. First and foremost is Unity events. If you've ever seen like a button or something like that in Unity, you'll see like onClicked or something like that. This is a Unity event. This is from editor, you can set up, okay, when something occurs, then I want something else to occur. Which isn't that image there. I can also just show it here. So in this case, I've set up another box collider that's on trigger enter. But this time, whenever something happens through a Unity event, we can do whatever I put in here in code. So I can say I have this other called events received, right? So I create a function. Okay, whenever something triggers this collider, I want to do there's also different things you can do, but I have a function called onEventsReceived, which will just print something out. So, again, note I have two separate objects that are not connected to each other in any way. And I'm going to move this physics cube through. Move this physics cube in there, and we have event received. And when we actually look at where this is called on a script that literally just has on event received. It has nothing else besides a public event. But if I go, I'll stop this, to events received, or testing events. We have a trigger enter, which we talked a little bit about earlier. And here's sort of the syntax to set that up. It's a public Unity event, and then whatever you want to call it. And then you just call invoke. And then whenever that occurs, anything that's set up in the editor will be invoked. Additionally, make sure you have to import Unity Engine.events in order to use it. So you just got to put that little bit on top. Otherwise, put those everywhere. If you are making a game with other people, anytime you think you're gonna obviously there are other ways to implement things, but it's nice to always have okay, when something significant happens, I want to be able to, from editor, have this exposed. And so I can either set up a sound effect, a VFX to occur, all sorts of different little functionalities. Even if you're not immediately going to use it, having this open to designers and programmers to use is really handy. Besides Unity events, C# has its own, I believe they are a C# event. So there's an alternative way of sort of doing what we just did, but entirely through code. So you don't have to set things up through editor and whatnot. And this is using delegates. A little bit more to set up in code, but then once it's set up, you don't ever have to manually drag and drop things in the editor for every individual object. This is for anything that's subscribed to an event will get this notification. So a little bit of weird syntax here, but basically you can do a public delegate. In this case, I'm calling it a test action, sort of like a function. And then I'm creating a static event called onTestEvent. So sort of got to learn a little bit of syntax there, but once you do that, you can actually come in here into another script or something like that, and you can subscribe to it from another one. So what I'm doing is on enable on this other object, I am saying I'm taking this testing event script and this delegate that I set up. If I do plus equals, and then you add a function, whatever function that you add, there's no special things you got to do for that function. It's just a regular function. If you add it, then whenever this occurs, then it will trigger anything on any other script that's subscribed to it. You can also it's good practice on disable to unsubscribe, which is just like minus sign. And then instead of invoke, we will have you just call onTestEvent as you would call a function, just with brackets. And then now I don't have to do anything in code or in editor, and this will just occur. So I'm actually going to just remove this, and we should still see the message occur from the other script whenever I play the game. Cube. Event received. So where Unity events are really good for creating open-ended situations, especially for designers and other people to put in, the C# delegate events are really good for specific instances. If you want, a lot of times if you have systems that should communicate in specific ways, or if you know something needs to occur, then this is typically the route. You can set it up with like input or so that's sort of pretty key differences between them, but very useful to set up in a lot of different situations, especially on more expensive games. You just need to know what a lot of things are going on at different times. Any questions? This is just a quick crash course on some of that stuff. So I do recommend, again, all this found on Unity API. I'll put out these PowerPoints a bit later, probably with even more details on it, with resources for you. And yeah. Otherwise, that's like all the sections I had. At this point, it's just a bunch of extraneous like little details that I think are useful. And then just questions, and yeah. All right. Let's see. What do I have first? First thing I just wanted to talk about is if you're coding, you'll notice next to your class name is a thing called mono behavior. I'm just putting this in here to say, hey, don't remove that, otherwise you're going to break it. This basically tells a class that it's going to be something you can put on a object, right? So the fact that I can see it here, just like a box collider, is because it's a mono behavior. 95% of the time, you're going to be writing scripts called mono behavior, so I just have it in there. But there are alternatives like scriptable objects, which can be its own workshop. Those are fantastic. Use them. I'm not going to talk about them today. Time. We sort of briefly talked about this before. Time has a bunch of functionality. It's literally capital T time, and there's several different things you can do with it. Most importantly, time.delta time is what you want to do. Time.delta time will get the how long it's been since the last frame, and if you are like moving something in update or stuff like that, then you want to multiply it by this, and it will make sure it's independent of frame rate, and it will smooth things out. Alternatively, another neat functionality of time is you can literally set the time scale. So by default it's 1, but if you set it to 0, everything will freeze. So if you're pausing the game, that's a good way. You can just freeze everything, and then you can set it back to 1, or you can speed up, and so you can do some cool debug stuff with it, or maybe you can do slow-mo and whatnot. But it does affect everything, so use it sparingly. Yeah. Whoa, I hit end, not next. I have this in here. I will try to talk about this because I think it's pretty important, but typically most things you want, you're going to have in Unity. You're going to have several instances of them, right? But sometimes you might just want a single version of an object in the game. So say you have like a manager. If you have like an audio manager that's going to manage all audio in your game, the music and stuff like that, you would only want one in your game. You can do that through specific syntax by basically saying, all right, I'm going to create a static variable, so there's only one variable of the same type. So I have this script that's called singleton example. I'm literally referencing itself singleton example called instance. I think most of the time the standard is an underscore in front, but that's sort of up to you. And then on awake, you want it to probably even before start, like before anything, check, am I not null? And am I not the same object as this one right now? If so, destroy me, and I'm out. If not, then set instance to this. What this basically does is, I have two objects called singleton, and they both have the same script. If I run the game, one of them gets destroyed, and you only have one left. So this is good to know for like your specific managers and whatnot. You don't want to do this on every object, obviously. This is for specific cases. And if you want to take it a step further, there's a functionality called don't destroy and load, where you put in the game object it's attached to, which you can always reference by just saying game object. And if I can load between scenes, and you can see in here it's in a section called don't destroy and load. I can go from like scene 1 to scene 2, level 3 to level 5, and this object will stay there as I go through it. Again, you want to only use this in specific cases, typically like overarching managers and systems. Otherwise, you don't want like things carrying through your game too much. Otherwise, that's a lot of baggage. But I did want to just show that off real quick. Syntax is on the slides. You can sort of write this in many different ways. This is one of the many ways to write this. Namespaces. This is sort of a way to organize and keep things things that shouldn't reference another thing from not. That was weird sentence. But basically, I have in here, so you can pretty much put in, if you have a class outside of your class, you can put it all inside of a thing called namespace. So in this case, I have namespace example. And this puts it in a thing called namespace. It doesn't really do much in the script that you're actually using it. But if I go, let's see, I have, I think in here. We'll just do it in here. If I wanted to reference this, for instance, typically I can call any script I have, right? I can just say, okay, I want to create a testing events script or object. I can do that. But I can't actually do that with the singleton example script. It doesn't give, it's not popping up, and if I type it out, it's having an issue. That's because I put it in a namespace. If I wanted to use it, I can say using. I got namespace example. Okay, how original. Namespace example. If I do that, just like how you would earlier with like the dot events and stuff like that, now it recognizes it. It's highlighted there, and then I can create just a variable with it. Yeah. So you might be like, well, why would I want to do this? Again, this is going to be, it's just good practice for like bigger systems. Maybe all your audio scripts, you want to be in the namespace audio system. And so if you ever want to reference it, you have to actually import it into your script that you're using it. it's more or less for better practice and coding conventions and stuff like that. Tags. They're a neat little thing in Unity. You can take any object. There's a little section here that's called tags. You can tag them. There's a lot of default ones. You can add your own tags. These are just an additional way to reference objects. I will say tags though are string based, so like string referencing things is a little, but you can. So do I have I have an example in here. So one sec. I can say, okay, is this game object that I have the script on tag player? If so, I can do something. Yes.
I was just gonna ask, does tagging stuff change anything about that, or is it literally just putting a label?
It's literally tagging it. I guess one thing to know is you can only have one tag on an object at a time, but you can have as many things tagged with the same thing, if that makes sense. But it is literally just putting a label on it, and just another way of referencing. It is nice, like sometimes I like to put tags on things, and on collision enter, if I'm tagged player, then do something because I'm the player who collided. Somewhat alternatively, there's a thing called layers, which also you could tag something with. It's right next to tags. You can add layers and stuff like that. Layers are neat because one, you can string reference, but also these are like actually numerical. So if you know your layers, you could reference layers through numbers or an enum if you wanted to set that up. And yet again, this is another way of just defining what an object is in a game. Another neat thing about layers, and this isn't necessarily coding specific, but if you go to edit project settings, you can actually, there's a little matrix here. You can define what actually collides with what. So with layers, you can define certain things to physically interact with others, and stuff like that. So if I wanted my water to not interact with my ignore raycast, then I can do that. Water, ignore raycast. There you go. Now they won't collide. We're nearing the end. Layers. Yeah, there's some code. Layers are really also nice for raycasting. That's another thing you can spend a lot of time discussing, but you can set up a layer mask for them, and either you could have it where only that layer that you set up will be detected by the raycast, or you can have it where everything but that layer is detected by the raycast, depending on syntax there, which I can describe some bit more, but if you want, ask me later or look at the syntax in the slides. Also, lerp, slurp, smooth damp, if you've ever used it before, here's a neat little GIF of the difference between them. So at the bottom, you have move towards. That is just something that's moving. That's just, there is no like smoothing of it. It just goes to its location. So you can see the difference between a lerp and a smooth damp, and a slurp is actually moving because that's a spherical. It's just a neat little thing I was shown, and so I just wanted to show y'all if you ever didn't know the difference between them. If you don't know what a lerp and slurp and all that is, don't worry. Yeah.
So slurp is for like rotations?
Yeah, it's typically I believe quaternion base, and so yeah, I think what's happening here is there's actually a pivot like in the middle of the screen, and it's moving, it's rotating about that.
I've never seen that used for anything but rotation, so I'm just curious.
Yeah, exactly. Otherwise, that's all my tips I have here today. Hopefully I didn't bore y'all too much. Appreciate y'all coming out for this. Hopefully you learned some stuff. But yeah, let's open up to questions. Yes?
Are the scripts that you showed us available on somewhere?
They can be. I'll make sure they're available. They're technically on my GitHub, but like I'll share that out and all that with this presentation, and we'll probably have a recording. Yeah.
To what granularity would you advise making singletons? Like, if you could reasonably assume that there's only supposed to be like one player and one camera, would it make sense to make those singletons, or would that lead to?
I think that depends. Yeah, so like for your instance of like a player and camera and whatnot, yeah, you would only have one per scene. But if your scenes are very separate, like this is level 1, now this is level 2, there's no need to make those singleton. You can just, because then you could just have the player in level 1 and player in level 2, and then whenever you start up, you transition scenes, it just is a separate player, but it's there in the other scene. But let's say you had a more interconnected game, open world, for instance, you would then have a lot of separate scenes, and yes, you would need your player to be a singleton that's going between these, walking between different scenes that are dynamically loading into the game. So it does sort of depend on your situation. I mean, typically, like, if you don't have to make a singleton, I think the advice is don't, but also don't feel bad if you do. Yeah. Any other questions? Cool. Yeah.
So, like, in the context of Unity, like, static variables, to use that, to use
I think it would.
it's pretty broad question.
Yeah, my answer would probably be similar to that, to the singleton. Yeah. It depends on your situation. I guess one I'd say I'm still figuring it out myself, but if you don't have to, then don't. But also, a lot of coding for games, especially, is cutting corners, and static variables is a nice and quick way of getting references to things. So, I wish I could give you use it here and here and here. Like instance is like the one case. It's like, yeah, you do use that for static, but yeah. Otherwise, I couldn't give you any more.
So coming from Java, I'm kind of used to
Yeah.
using getters and setters for most
Oh yeah.
private variables, but I've seen the convention for C# and block entity stuff is just using public. Is that, like, should we just be, is there a difference when we should be using those?
Yes. Actually, that's something that would be neat to include. There's a bunch of different ways to get and set, like syntax-wise. But personally, I still get and set because I also started with Java and whatnot. So by all means, create getters and setters. There are some shorthand ways you can write it in code that, like, you can do literally in one line a get and set if it's something simple. But it is that one is a bit more personal preference. Yeah, it is, and there are shorter ways of writing it. And I don't personally think you have to do it for every variable. Actually, for a lot, especially in Unity, especially since you're writing, if it's exposed in editor, not really. So yeah. Cool. Alrighty. Thank you. Yeah, the coding. Woo. Well, thanks y'all for sitting through that for an hour and 20 minutes. Good. I hope everyone learned something. I wasn't too bored. Yeah.